Hello, here we go. Talking about hot stuff. Not me, chemistry. Exothermic and endothermic reactions. Okay, therm makes me think of like thermometer, which is like temperature or heat. Energy is the capacity for doing work or supplying heat. So energy equals work or heat. Unlike matter, energy has neither mass nor volume. Energy is detected only because of its effects. A hot water pot, a speeding car, an explosion. Thermochemistry is the study of how energy changes in a chemical reaction and changes in state. Sounds important. So that's the definition of thermochemistry. The energy stored in bonds is called chemical potential energy. So stored is potential, while the energy from moving atoms is called kinetic energy. So moving atoms is kinetic energy. Reactions either give or take energy when they react. Sounds important. This heat, Q, why? H I get, I'm looking down here already. Q doesn't make sense, but okay. So heat is Q, is called the heat of reaction or the enthalpy of reaction. Triangle H, delta H. So this is a delta. Delta H is the enthalpy of reaction. At constant pressure, the enthalpy of reaction is equal to the heat change as well. So delta H equals Q. Thus Q and delta H can be used interchangeably, so either one. In more advanced chemistry, this is not always true. If the heat of reaction is negative, that means the system has lost energy and the reaction is exothermic. So negative means lost energy, exo. So this one, delta H is less than 0, is negative. So we lost energy. Heat is exiting the system. If the heat of reaction is positive, that means the system gains energy and the reaction is endothermic, heat is entering. So here this is the opposite. This is positive delta H. Endothermic, gain energy. So here the heat's going in, here the heat's going out for exothermic. All reactions require some energy to get started. This energy is called activation energy. So, to get going. My wife requires a lot of activation energy in the morning. That's what coffee's for. It should not be confused with the heat of reaction. For example, cars burn gasoline in order to move, which is a highly exothermic reaction. Yeah, the gas is releasing energy. The burning of gasoline releases energy, I said that the car uses to move, and much of the energy is also released as heat. I guess that's why it's hot. However, in order for this reaction to occur, the battery must supply some energy to the spark plugs to ignite the gas in the engine. This initial spark is the activation energy. Okay. So although some energy is added, the spark, to start the reaction still releases much more energy than it absorbs and is exothermic. So I guess an endothermic, even though it would still take a little activation, would absorb more than it releases, I guess. Okay, interesting.